So this is the last day of notes for chapter 1. It's kind of been out of order. I do apologize, but between, trying to get some review days in and me being gone for a couple days, we are a little bit behind everyone else. If you have any friends with another Algebra 1 teacher, they did this last week. We're going to do it this week. We'll be all on the same page by the end of this week, so no worries, okay? Last day of notes, like I said, this is day 15 for this chapter. It's all about absolute value equations. We've talked about absolute value before. So do you guys remember what those bars mean? Yes. Yeah, so normally anything you would put inside of here would become a positive. So what are two values for x that would work here? Negative 7 would work for x. That would give us a solution of 7. Also, 7. So the two solutions for x here would be 7 and negative 7. Because the absolute value of 7 is 7. The absolute value of negative 7 is also 7. Okay? Any questions so far? So, here's our first equation. Write this down. I want to find the values for x that would give me an answer. When I take the absolute value, I would get negative 9. What numbers have an absolute number, or numbers have an absolute value of negative 9? You all look very confused. Why are you confused? Absolute value can't be negative. You are absolutely correct. The absolute value can't be negative. Okay? So, this has no solution. Anytime you see an absolute value equals a negative, don't even do any math. Just immediately write no solution. Okay? That's if there's the whole absolute value sign. Sometimes it'll have like a times negative 3 or something, and then you can do a little something with it. Might work out, might not. In this case, though, just the absolute value of x equals a negative number, not going to happen. Questions? All right. Here's one we can actually do. So the absolute value of x divided by 2 equals 12. Yes. That's one of our solutions. First of all, we want to think of the two different scenarios here. So what's in the absolute value symbol can equal positive 12, but it could also equal what? Negative 12, right? This whole thing could be negative 12, and when we take the absolute value, we'd still get positive 12. So you have to set up both scenarios when you're doing absolute value problems, okay? Because if I get a 12 in here, my answer is still 12. If I get a negative 12 in here, take the absolute value, you still get 12. So I need to solve two separate equations. But yes, you are correct. One of the answers is going to be 24. What's the other one?
Wait, what? No, she said you multiply 2 by both sides. I thought she said 12. You thought wrong.
Yes, multiply both sides by 2. And what do you get on the other one? Negative 24. Good. Now, for absolute value, I always double check because these kind of get weird. I don't know. It doesn't always feel like I did it right. I just like to be a little more confident. Plug it back in. 24 divided by 2 is 12, and the absolute value of 12 is 12. This one checks out. Negative 24 divided by 12 is what? Negative 12. What's the absolute value of negative 12? 12. This one works out as well. Questions? All right. Part C. The absolute value of m plus 8 equals 20. All right. So what are the two options for m plus 8? They could equal what and what? 20 and negative 20. So I'm going to set up one equation equals positive 20. Set up another equation, m plus 8 could equal negative 20. How do I get the m by itself? Subtract 8. What is 20 minus 8? 12. 12 is one of my solutions. Solve it the same way, but what's negative 20 minus 8? Negative 28. Good. So there are my two solutions here. Once again, you can plug them back in. 12 plus 8 is 20, and the absolute value of 20 is 20. Negative 28 plus 8 is negative 20, and the absolute value of negative 20 is 20. So we have the absolute value of 3x minus 2, and that equals 7. So 3x minus 2 could equal two things. What is it? 7 and negative 7. So 3x minus 2 equals 7. 3x minus 2 equals negative 7. And then we solve them both individually, and we will have two solutions, and then we can check those two solutions. So what's the first thing I do here? Add 2 to both sides. 3x equals 9. Then what? Divide both sides by 3, and we get x equals 3. Good. Okay, so that's one of my solutions. What do I do on the other one? You add 2 again. This time you get what? Negative 5. And 3x equals negative 5. What do I do next? Divide both sides by negative 3. And you just get negative 5/3. When I plug them back in, 3 times 3 is 9. 9 minus 2 is 7. The absolute value of 7 is 7. This one checks out. When I plug this guy back in, the 3 and the 3, those are just going to go away, leave me with the negative 5. Negative 5 minus 2 is negative 7. What's the absolute value of negative 7? 7. So these both work. I am confident that those are my solutions. Did you all hear the question of, do you need both of these on your quiz?
Yes.
Yeah, you do. These, you can't just give me half the answers. It's not going to work out. So yeah, you need both of these in order to be correct. All right. Part E, I sort of hinted at this sort of setup at the beginning, but we cannot take, we cannot consider the positive and the negatives that will work with the absolute value until the absolute value part is by itself. So first you want to sort of solve for the absolute value, then you want to do the positive and the negative. So how would I get rid of the multiplying by negative 4 that's out front right here? Yeah, you just have to divide both sides by negative 4. You don't do anything in here. All this does is get rid of this negative 4 out front. And then back here, what's negative 24 divided by negative 4? Positive 6. So I now have the absolute value of 3 minus 1/4 x equals 6. That's where I can set up the two options. So what's inside the absolute value symbol can equal what? 6 or negative 6. So write your two equations and then solve. The trick here, or I guess one of the troubles here, is if you solve it wrong once, you're probably going to solve it wrong again. So I want to get rid of that positive 3 first. So what am I going to do? Yeah, I need to subtract the 3 from both sides. That gives me negative 1/4 x equals positive 3. How do you get rid of this? Multiply by the reciprocal, which would be negative 4 over 1, which is just negative 4. So those are gone on the left. I have x equals what? Negative 12. All right, what about the second equation? Subtract 3 from both sides. What is negative 6 minus 3? Negative 9. So I have negative 1/4 x equals negative 9. Then what? Multiply both sides by the reciprocal, which is, yeah, still negative 4 over 1, or just negative 4, which gives me a positive 36. This is one where I would love to plug it in and check. So negative 12 here, it's a negative times a negative. The 4 in the denominator and the 12 in the numerator give me a 3. So it's like 3 plus 3, which is 6. The absolute value of 6 times negative 4 is negative 24. Back here, when I plug in a 36, what's 36 divided by 4? 9? And what's 3 minus 9? Negative 6, and the absolute value of negative 6 is 6, and 6 times negative 4 is negative 24. So they do both check out. I am confident in boxing in my answer and moving on. Questions? All right, here's F. It says 3x minus 1, that's absolute value of that quantity, plus 2 equals 8. All right, what should I do first?
Subtract 2.
Yeah, subtract 2. You got to get these by itself, this bars, you know, the absolute value symbol. You got to get that by itself before you can do the plus and minus. So yes, I'm going to subtract 2, and this is actually the absolute value of 3x minus 1 equals 6. Then what?
Now we have to find out which solution.
Yeah, so 3x minus 1 equals 6.
And 3x minus 1 equals negative.
Equals negative 6. Perfect. You guys are getting the hang of it. All right. What do I do here? Add 1, add 1. Good. What is 3x equals 7? Then what? What do I get? 7/3. Don't make it some weird decimal, okay? Leave it alone. All right, when I add 1 on the other side, do I get a solution that's any prettier? Not really. You get 3x equals negative 5. Divide both sides by 3. Negative 5 over 3.
Oh, wow.
Questions? Okay.
We need to see which one was right.
What? They're both right. Oh, you want to check the answers? I love it. Okay.
She just skipped.
When you plug 7/3 in, you get 7. 7 minus 1 is 6. The absolute value of 6 is 6. 6 plus 2 is 8. That one checks out. here, when you plug this in, the 3's go away. You have -5 minus 1 is -6. The absolute value of -6 is 6. 6 plus 2 is 8, and it checks out. I'm glad we stopped and checked because anytime you have variables on both sides and you're doing the absolute value, it might not check out. So we've been sort of, I'd say like casually checking our work. When you see variables on both sides, you need to definitely check your work, okay? Because there are these extra solutions that look like they're going to work, but they actually don't. Those are called extraneous solutions. Again, the tip-off, I say check all the time. But casually, you know. These you want to check like hardcore, okay? When you see variables on both sides. So the setup here is basically the same thing. You want to set this equal to this whole thing, positive. And then you want to set it up, 3x minus 4, to this whole side, but negative. Same thing. If this was like a 9, we'd set it up to equal positive 9 and negative 9. Same idea. We just have x's on both sides. We have absolute value on both sides. So we're going to leave the left side alone. Equals the positive, just as you see it, but also the negative. The trick is you can't just make the x negative. And you can't just make the 6 negative. You have to make them both. So that's why we use parentheses. And sometimes when you're taking the absolute value of so many things and you start with variables on both sides, these random solutions will pop up and they don't actually work when you plug it back in. So we're going to see if that happens here. Solve like normal. Get your x's together. 2x minus 4 equals 8. Equals 6. Then what? Add 4. 2x equals 10. Divided by 2, x equals 5. On the other one, you have to first distribute the negative. It's like multiplying the terms inside the parentheses by a -1. Now you get your x's together. So I'm going to now add 1x to both sides. So it sort of changes the whole way the problem works out. Then what? Add 4 to both sides. Divide by 4. So these are my two solutions. Since I'm being a little more serious with checking my work now, again, the tip-off is absolute values on both sides, variables on both sides. You definitely want to be a little more serious with your checking. So I am going to plug the 5 in first. This gives me 15 minus 4. What is 15 minus 4? 11. Absolute value of 11 is 11. Equals, what is 5 plus 6? 11. What's the absolute value of 11? 11. So this one does check out. I feel good. I'll give you a second to write this out because I want you to remember that we are a little more serious with our checking at the moment. Shh. Please stop with the singing and the talking and the random like mumbling. All right, checking the negative 1/2 is a little bit trickier. We get negative 3/2 minus 4. You would need to either type it in your calculator or get common denominators. Common denominators would be 2, so it'd be like 8 over 2. So it'd be negative 3 minus 8 all over 2, so negative 11 over 2. Here, again, common denominators, so it'd be like negative 1 plus 12, right? Because the common denominator would be 12 over 2. This one actually does check out for both, so you're good to go. But again, variables on both sides, absolute value on both sides, we're going to be a little more serious with our checking. Questions? Now, we don't have absolute value, the symbol on both sides. But this is still one where I would check for extraneous solutions. Because, again, I'll say it a lot. Say it over the next couple review days. When there are variables on both sides, when there's absolute value symbols on both sides, those are tip-offs. Something might not work out in the end. Okay? So, what am I going to do right now? Make your two problems. X minus 3 equals 2x. X minus 3 equals negative 2x. All right, I got variables on both sides, so I'm going to subtract the x first. And in that first one, I love when this happens. 2x minus 1x is just x, so x does equal negative 3. On the other one, you could still subtract the x from both sides. That's not the way it's programmed, so I'm just going to go with the way that it's going to pop up here. The reason I don't typically do it this way is because of this. You get a 0, but you can still just add the 3 and then divide by the 3, and you get that x equals 1. The way I probably would have done it, I'll just show you for a second, and then it's going to have to go away. I probably would have just subtracted the x, right? So you'd have negative 3 equals negative 3x. And then when you divide, you still get the 1. Okay? Either way is fine for that one solving. Now what? Check. And I'm going to check a little more seriously than I've been checking. Okay? So I'm going to first plug in negative 3. Negative 3 minus 3 is what?
0.
No. Negative 6. And what's the absolute value of negative 6? 6. What is 2 times negative 3? Negative 6. But I don't have an absolute value over here. So can I magically make them both positive 6s? No. Is this a solution?
No solution.
No. Get rid of that. It might not be no solution because we still have the 1 to check. But we're definitely going to limit our solutions here. When you plug the 1 in, what is 1 minus 3? Negative 2. What's the absolute value of negative 2? 2. What's 2 times 1? 2. Does this one check? Yes. So on your test or quiz or your worksheet tonight, you could just put x equals 1. Or if you want to just cross it right out, like in your work, I'm okay with that. I'll know what it means. Again, this is called an extraneous solution. These do not come up on the calculator. So let's say your favorite thing to do is those math calculators that like do all the work for you. This wouldn't even show up. It would only give you the one that works. That's why a lot of standardized tests are starting to ask, what are the extraneous solutions? Because there is no technology right now that will tell you the extraneous solutions. Kind of cool, right? A little fun, like behind the scenes insider information. All right, summary today. What are these called? Absolute value equations. Good. Okay, you have two things that are due tomorrow. Tomorrow. You need to have the day 15 worksheet, which I am about to hand out, and the one from Friday, which is a little out of order, but it's the day 16 worksheet. Now, there were a few problems on the day 16 worksheet that you might not have been able to do because they were absolute value problems since we went a little out of order. So if you ran into any issues with those, you can fix them by tomorrow. But I need to see both. 2 days of homework, both due tomorrow.